Hey everyone, today we're going to do a tutorial on MCNEMAR'S test. This is going to be the first of two tutorials on MCNEMAR'S test. I'm going to do one now, and then Lauren is going to do another one coming up next using the data from the CHIS dataset. So for this example, consider the following study. So we want to compare two different screening tests for determining adrenal insufficiency. So just a little background, adrenal insufficiency is a condition in which the adrenal glands do not produce adequate amounts of certain hormones. So the screening test for this disease involves measuring a patient's cortisol response after administration of an IV bolus of ACTH. So 2 doses of ACTH are used, 1 microgram and 250 micrograms. But there is a debate as to which dose should be used for the initial assessment. So the goal of this study was to compare the cortisol response of the 1 microgram and 250 microgram ACTH test among patients with suspected adrenal insufficiency. So after patients received the ACTH stimulation, they were then classified as having either adrenal insufficiency or not based on their cortisol response. This was a retrospective cohort study where patients who received both tests were included in the analysis. So we have paired data here, and so what our data are going to look like is we're going to have a 2x2 table, and we're going to have the results of the 1 microgram test on one side and the 250 microgram test on the other side. And then we're going to cross-classify patients. So patients would come in, get the 1 microgram test. They'd be classified as either abnormal or normal. And if you're classified as abnormal, then you're classified as having adrenal insufficiency. So they would come in for that test, get a result, and then a few days later they would come in for their 250 microgram test, and they would get another result, either abnormal or normal. And we're going to basically cross-classify these patients. There's N patients. So depending on, if you came in for the 1 microgram test and were normal, and then for the 250 microgram test were classified as abnormal, you'd be in this category, and so on and so forth. So we have paired data, and we want to use MCNEMAR'S test. So what's our null hypothesis here? Our null hypothesis is that the proportion of patients classified as having adrenal insufficiency using the 1 microgram test is the same as the proportion of patients classified as having adrenal insufficiency using the 250 gram test. So basically the proportion of patients classified as having adrenal insufficiency are the same between the two tests. And the alternative is that these proportions are not equal. Now this null hypothesis, is it the same as testing that the proportion of patients classified as not having adrenal insufficiency using the 1 microgram test is the same as the proportion of patients classified as not having adrenal insufficiency using the 250 microgram test? So if you think about this for a second, the answer is yes, and the reason is because if the proportion of patients classified as having the disease are the same, then there's only 2 categories patients could be classified in. So if one proportion is the same, then the other proportion has to be the same. So if the number of patients classified as having adrenal insufficiency are the same for both tests, then likewise the proportion of patients classified as not having adrenal insufficiency have to be the same as well. So these are in fact the same null hypothesis. It just depending on how you want to specify it, but they are in fact the same. So now let's go to Stata. The data are located in the AI.dta dataset. Okay, now we're in Stata. We have 2 variables here, as you can see, 1 and 2. And let's use the tabulate command to look at our data. So type in tabulate 1, 2. And so the variable 1 is the results of the 1 microgram test, and the variable 2 has the results of the 250 microgram test. So now we can cross-classify these patients. You can see we have 207 total patients. And for instance, 132 were classified as being normal on both tests. So what we want to know when we use MCNEMAR'S test is how many discordant pairs are there. And so discordant pairs are people who were classified differently on both tests. So for instance, 19 people were classified as abnormal on the 1 microgram test and normal on the 250 microgram test. Likewise for these 14 patients as well. On the 1 microgram test, they were classified as normal, and on the 250 microgram test, they're classified as abnormal. That leaves us with a grand total of 33 discordant pairs. Now, ideally, we would like these tests to agree. Ideally, we'd like to see 0 here, and we'd like to see 0 here as well. So the tests agree with each other. But that is not the case here. So we're going to carry out a test. We're going to carry out MCNEMAR'S test with alpha equals 0.05. So the command for this is MCC. So you're going to want to type in MCC 1, 2. And so as you can see, you get this nice table that says cases and controls. So let's ignore that because we don't have cases and controls. So what we do have, so these controls are really the 250 gram test, and these cases are really the results of the 1 microgram test. And exposed here corresponds to normal, and unexposed obviously corresponds to abnormal. So as we can see from this, our test statistic is 0.76, and under the null, it's distributed as a chi-squared with 1 degree of freedom. And our p-value that we get is 0.3841. Now, MCNEMAR'S test is based on the binomial distribution, and there's also an exact version of MCNEMAR'S test. And so this gives you a p-value of 0.4869. And so this was actually the p-value reported in the paper. So since our p-value is greater than 0.05, we fail to reject the null hypothesis. So what we can say here, we don't have enough evidence that the proportion of patients classified as having adrenal insufficiency using the 1 microgram test is different from the proportion of patients classified as having adrenal insufficiency using the 250 microgram test. So we don't have any evidence that these proportions are different, which is nice. Hopefully we would like these two tests to agree with each other. So that's a nice conclusion. So that's all for this example. And like I said, Lauren will do another tutorial on MCNEMAR'S test coming up next.